All right, let's explain the meaning of the slope of position versus time graphs. This is part one. A position versus time graph is plotted with time on the x-axis. It's going to be at the bottom, and position is on the y-axis. And position is measured in meters, and time is measured in seconds. When we think of position, I want you to think of like a distance. So when we measure position, you got to imagine a camera taking photos of an object every 1 second. So we have this turtle here, and this turtle, he's jumping up and down, but he is at his starting point right here at the origin. Now he's there at the origin, which is 0 meters away. And let's take a photo of him every second. 0 Mississippi, 1 Mississippi, 2 Mississippi, 3 Mississippi. So we got to 3 Mississippi, so right now, frozen in time, young turtle here is at time equals 3 seconds in time. And his distance, he's gone 1, 2, 3. There's no units here, but let's call each one of these like a meter. So he's gone his distance, which is the same as his change in position. So he's changed his position from 0 to 3 meters. So his change in position is 3 meters. So at t equals 3 seconds, his position is 3 meters away. And his total change in position is 3 meters. Easy enough. Okay, the position is the distance away from the origin. Distance away from the origin. And a change in position, objects that are moving faster will have a greater change in position. And that makes sense. If you're moving faster, your change in position is going to be greater. But let's see it with this hare here, the tortoise and the hare. 0 Mississippi, 1 Mississippi, 2 Mississippi, 3 Mississippi. So here we are at the same moment in time at t equals 3 seconds. And look, he's gone quite a bit more in distance here. He's gone all the way. He's at about 6 meters here. Oop, doop, doop. Erase those lines here. We don't need them. So his distance, or his change in position, he's at about 6 meters. Now, I just want you to look at the difference in these gaps here. So look at how much more ground, little rabbit, or hare, I guess. I don't even really use the word hare for rabbit, but so it goes. The distance between each one of those gaps is bigger for that rabbit. Makes sense. Okay. Next, we got this crazy lizard here. Here's Mr. Crazy Lizard. He's going to start here at position 6 meters. So he doesn't start at the origin. He starts at 6 meters away from the origin. Origin is still right here. And when I say go, he's going to go. 3, 2, 1, 0 Mississippi, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi. So, cool. He is now at position. His position is, oh my gosh, let me just zoom in so I can write this a little bit more neatly. So his position here, he's at 0 meters. So he's gone from 6 meters to 0 meters. So I could say that his change in position is negative. His change in position is negative 6 meters. Boom. Okay, so just remember, negative change. Objects that move towards the origin have a negative change in position. Let's fill that in, negative. Cool. Usually, and when I say usually, I mean always in my class, when we say to the left, we mean negative, and when we say to the right, we mean positive. And if it's an object that's going like up or down, like a rocket ship, up is going to be positive and down is going to be negative. That's called a convention. That's a convention that we'll use. And we'll make sure to keep that the same every time. That way, when we specify position, we can also specify in what direction. It's important. Cool. So this is the meat and potatoes of this video here. We got to talk about position versus time graphs. So In green, I have the turtle. And at second number 1, so here's time at the x-axis. At second number 1, he was at 1 meter. At second number 2, he was at 2 meters. 0 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6. And I'm just plotting where he was at each time interval. So remember, at 3 seconds, he was at 3 meters. So that's a plotted point right there. So just remember where these graphs come from. And then I could draw like a nice best fit line. Shoop, boop. And that represents, that's green, so that's my tortoise, or my turtle. Tortoise, it's a tortoise. It always has been a tortoise. And let's look at our rabbit. So what color is our rabbit? He was like gray. So at 6, 0 Mississippi, 1 Mississippi, 3 Mississippi. At 3 seconds, remember he was at 6 meters. Let's check again. Yep. At 3 meters, I'm looking right here, folks. At 3 meters, or sorry, at 3 seconds, he was at 6 meters. So at 3 seconds, he was at 6 meters. I did the over and up method. That's what that sound effects was. Boom. So we can assume here, let's just fill in the gaps. At 1 second, he was at position of 2. Let me get my thing here. Boom. At 1 second, he was at a position of 2 meters. At 2 seconds, he was at a position of 4 meters. And at 3 seconds, there he was at that 6 meter mark. So he was going a lot faster. And this is his position versus time graph. It looks like that. Notice the slope. Notice the slope. That's the important thing here. Lizard guy. Do we have a name for him yet? Not yet. He started at 0 seconds. He was at 6 meters. And at 6 seconds, he was at position 0. I don't know if you saw me draw those. And so we can assume, let's just fill in the rest. As he was going at 1 second, he was at the 5 meter mark. At 2 seconds, he was at the 4 meter mark. At 3 seconds, he was at the 3 meter mark. And then 4 seconds, the 2 meter mark. And at 5 seconds, the 1 meter mark. And then so we can draw his line. So here is his line on the position versus time graph. And notice the slope. It's negative. I'm having too much fun. Okay, look at how beautiful those graphs are. So calculating velocity. So here, when someone says explain the meaning of the slope of a position versus time graph, let me say that. Let me clear that up and say that a little bit faster. When someone says when you want to calculate what's the meaning of the slope of the position versus time graph, you can tell them, guess what? The slope, the meaning of the slope is the velocity. So what does that mean? Let's look at Mr. Rabbit and the tortoise. I keep saying rabbit. It's a hare. Is there a difference? I don't know. I'm not a biologist. So here we have time 3, 6. We have this spot, and let's use the origin, 0, 0. So if we're looking at the slope here of this spot and this spot, we have a rise of 1, 2, 3, 4, 5, 6, and a run of 1, 2, 3. So our slope here is of the rabbit. I'm in gray to tell everybody that I'm talking about the hare. We have a rise of 6 and a run of 3, and our slope is 2. But in physics, you never forget your units. The units of the rise, the variable's position, the units are meters, 2 meters, and the run, the variable is time, but the units are seconds, and the run is seconds. So the slope is 2 meters per second. And just like in a car where you're going miles per hour, we have 2 meters per second. So that's our units for velocity. So the slope of a position versus time graph is the velocity. So you can, if someone were to ask you, how fast is the rabbit going? The hare is going 2 meters per second. Quickly, we have tortoise. let's just use these 2 points because it's easier. The slope is rise is 1 over 1. 1 meter over 1 second. So what is 1 meter divided by 1 second? 1 meter divided by 1 second is 1 meter per second. That is the units of the rise and the run. So if someone were to ask you how fast is the tortoise moving, the tortoise is moving 1 meter per second. And that makes sense to us because we just watched him cruise across that little zone up there. Capiche? Cool. Oh yeah, one other thing. Are these slopes positive? They are. That's a positive slope. That's because the rise, I'm in green, right? Rise is positive. We're going up. So we have a positive slope. And let's look at the lizard. Finish us off here. The slope is negative, so we know we're going to have a negative velocity. And let's just use this point and this point, the 2 lattice points here. If I go down 1, 2, across 1, 2, we have a rise of -2 and a run of +2, which means that our slope here, slope equals -2 over 2, which equals -1. And in physics, we never forget our units. And the units of a position, the units of the slope of a position versus time graph are meters per second. Okay? So that's how fast this guy is going. -1 meters per second. And we actually say that. The velocity of the lizard is -1 meters per second. We actually use the negative. Even though you won't say that in your car, I'm going -30 miles per hour. In physics, we use velocity, not speed, and that's why we specify the negative, positive, which tells us the direction. Wow, there's a lot in there. So, the sign of the velocity, memorize this, people. The sign of the velocity tells you the direction. When I say sign, I mean, is the slope positive or is the slope negative or is the slope positive? If it's the velocity negative or is the velocity positive? So the sign of the velocity tells you the direction. So you're going left, going right. So in summary, when you want to explain the meaning of the slope of a position versus time graph, you can just respond that the slope of a position versus time graph is the velocity. How fast you're going and what direction. Cool. Beautiful. Thank you, tortoise, hare, and lizard.